ABYC is never contradict the federal law. ABYC is a good complement, and I recommend follow the regulations of ABYC. ABYC review and adjust regulations to keep up change in the industry. Yeah, ABYC is working together hand with the industry. The majority of the manufacturers, the marine manufacturers, are part of ABYC, are members of ABYC. In this schematic we have the fuel tank. The fuel tank is over there, and this is the transfer pump. Those are the water separator filters or primary filters. This is the secondary filter, and this is the priming pump or lifting pump, and this is the fuel injection pump. That's the fuel injection pump. Okay, the fuel injection pump is the element that multiplies the pressure hundreds of times. Let me explain something. This pump, the fuel transfer pump, this one, is a low pressure pump. It's a pump that normally works, it's a 12 volts or 24 volts connected to the ignition system. This is the pump that you hear when you select ignition. That's the pump that bring the fuel from the tank into the fuel injection pump at this point, into the fuel injection pump here. Alright, and of course the diesel engines, the troubleshoot is believe me, is very simple in comparison with gasoline. Why? Yes, because you don't need to follow a million of wires with signal for a spark. In diesel engine you only need that the piston compress the air and that the injector open. That's it. If the piston compress properly, if the compression is good, the piston compress the air appropriated. If the injector open, the engine starts. You don't need a spark, you don't need nothing. It's too simple. The compression is good, the injector open, that's it. The troubleshoot is simple in comparison with gasoline. Mr. Lopez, but my diesel engine is electronic, it's complicated. No. Look at this. This is a mechanical fuel injector. Input and return. All the injectors have input and return. This one works with the pressure of the fluid. If the pressure is enough, the spring internally compress and inject the fuel. We are going to explain later this element. This one is too simple. This is the input and this is the return. That's the return, that's the input. And here the signal coming from the computer activate the solenoid and spray the fuel. Yes, no, depending if the signal is coming from the computer. This and this are the same. Mr. Lopez, and what about the electronic fuel injection system? The electronic fuel injection system is basically pretty similar to the mechanical fuel injection system. Once again, we have the fuel tank, we have the transfer pump, we have the primary filters, we have the secondary filter here, that's the secondary filter, we have the priming pump. This is a manual priming pump. You can prime with your hand. If you don't want to use that one, with the electrical, with this one, you can prime the system. You can bring the fuel into the fuel injection pump. I recommend install the electrical, the 12 volts low pressure pump or priming pump. And this is the fuel injection pump. The fuel injection pump is located here. That's the input of the fuel injection pump, and this is the output. Look at this system. This is electronic fuel injection pump common rail system. Look, the output of the fuel injection pump, high pressure, more pressure than the previous mechanical fuel injection system. You remember in the previous one the output is in between 2000 3000 psi. In this one probably is higher. Okay, and with that pressure, pressurized this common high pressure rail, and that common rail send the fuel at high pressure to each injector, and each injector receive the current to be activated from the computer. And what is the difference between grounding conductors and grounded? Okay, the grounding conductor is basically the green cable that connect the case of the elements to the bonding system. Those green cables are the grounding cables. Those cables are considered non-current carrying conductors because normally you don't have current on those cables, on those green cables. Those green cables are installed for emergency in order to drain currents. What type of currents normally is moving on those cables? Small DC currents, a small static current. All right? Oh, and what happened during the storm? Okay, in some situations, drain heavy AC current. If you have a short on the water heater, drain AC current. If you have a short in a generator, drain AC current. But normally, drain those grounding conductors, they drain a small DC current. Okay, what is this is a grounding conductor. Is the green cable and is normally non-current conductor. Okay, the other one is the grounded conductor. The grounded conductors. Those cables are current carrying conductors. For example, the negative of the batteries. The negative is considered the grounded conductor and is current carrying conductor. Remember, the same amount of current flowing through the positive is returning through the negative. Yeah, those are current carrying conductors. The name of the black cable, the negative cable, the return, is the grounded conductor. That's different. Grounding conductor are the bonding cables. And grounded conductor is the return. The hose clamps. My friends, use appropriated hose clamps, marine grade. Marine grade is stainless steel, series 300. Those are the hoses appropriated. Okay, recommendations about the installation of the hose clamps. The clamps not to overlap each other. What is the meaning of that? The recommendation in all the fittings with hose is double hose clamps. Mandatory in all the fittings. Double hose clamps and the hose clamps cross. With the end of this, the end of the second one facing in the other direction. Cross. And separated. 1/4 inch in between both of them. Never that this one lap the second one. Separated a 1/4 inch and marine grade and opposite position.